Welcome to lecture series on database management system. In today's lecture series, let us discuss about the transaction concepts. So before going into the topic, here is the outline of what we are going to see. So we will see what about the transaction concept, the various states in a transaction, concurrent execution, serializability, uh, and after serializability, we will see about the locking protocols and we also see about recoverability. So before defining what transaction is that, let me explain an example. So consider the following example. Initially, I want to transfer amount, say for example, $50 from one account to another account. So let us assume I want to transfer the amount from account A to account B. So what I will do initially I'll read account A. So for it, so when I read account A, it means that I'll check the balance of account A. So once I found sufficient balances in account A, what I will do next is I will deduct $50 from account A, which is the amount I want to transfer to account B. After deducting that amount, I will credit or wire that amount to account B. Before that, I have to update the balance in account B. Say, for example, let us assume initially the account balance in account A is 500. After deducting rupees 50, the balance will become 450, which need to be updated in account A. So now the balance has been updated in account A. So everything from account A side is committed. Now let us move on to account B. So what I will do, I'll read the balance of account B. So say for example, the initial balance is 450 rupees. So once I read the balance, what is my transaction task or what is my task here? I'm transferring 50 rupees or $50 from A to B. So from A it is detected, whereas in case of B, the amount 50 rupees will be credited. So the initial balance will be updated with 50 rupees. So 450 plus 50 will become 500. So once I have transferred the amount, I will update the balance in account B, which is described in right B. So this entire process is called as transactions. Hope you understood what is transaction by this. Now let me define what is transaction. Let us have a look at it. So a transaction is defined as a unit of program execution that access and possibly update various data items. So here, by means of unit of program execution, here I have described 6 steps to transfer amount from account A to account B. So entire 6 steps is considered as a single unit of execution. None of these contribute to separate execution, right? Altogether, these 6 steps are considered as single unit of execution. So this single unit of execution is called as transaction, which updates various data items. Here, the data items are account A and B. Account A and B are updated. So the transaction is a single unit of program execution which updates various data items. However, this single unit of program execution will contain various subtasks. So all these 6 steps are considered as subtasks of this particular transaction. So when you look at this transaction, you could see there are two main issues that may occur. For example, if there is a system failure or if there is a hardware failure, it may have its toll on transaction. And if there are concurrent execution of multiple transactions, this is another major issue that needs to be dealt with. So you understood what is transaction and with the help of an example and what are the major issues that you need to deal with. So this is the same example that we have discussed before. Here we have an atomicity requirement. Say for example, I have detected amount from account A and even I have updated the balance in account A. After doing all these things, let us assume the transaction fails. Here, you can correlate with this your day-to-day GPay transaction, Google Pay transaction. You might have come across issues like from your account amount would have been deducted, whereas to your friend's account amount would not have been credited. Same is discussed over here. So if the transaction fails after step 3 and before step 6, So money will be lost, right? Because it has been debited, but it has not been credited. So money will be lost, which leads to an inconsistent data state. Now the database is not consistent. By means of consistency, we say that database should stay up to date. Here, database does not stay up to date because the amount has been detected, but it has not been credited. So it leads to inconsistent database state. And the second case is that failure could be due to software or hardware. So here, the system has to ensure that uh, the updates of this partially executed transaction. Here, the transaction is not completely executed. Here, the transaction is partially executed. So this partially executed transaction should not be updated in your database. This is what the system has to ensure. So this is called as atomicity requirement of a transaction. Next, let us discuss about another requirement, which is durability. By means of durability, what is the general meaning of durability? We call durability as long lasting. We check, for example, if you want to construct a building, we have to check the materials which are being used, like steel and rods are durable, right? So durable, say, stands for long lasting. So same is applied over here. So once the user has been notified that the transaction has been completed. So what is the transaction that we have discussed over here? Transfer of amount $50 from one account to another account. So if the user has been notified that this particular transaction has been completed or updated, so the updates that has been made to the database should exist even if there is a system failure, like even if there is a software failure or hardware failure. In other words, I can say, like, irrespective of software and hardware failure, all the updates to the database by a particular transaction should persist. This is called as durability requirement. So next is another most important requirement of transaction, which is consistency requirement. As I have said earlier, by means of consistency requirement, we say that the system or the database should stay up to date. So that is what which is explained over here. So consistency, how do we ensure the consistency in a database? With the help of constraints. So when we are discussing about SQL, we have seen various constraints such as integrity constraint, data constraint, referential constraint, key constraints. So all those constraints helps in ensuring the consistency of a database. So let me give an quick recap of quick overview or recap of this. Uh, integrity constraints such as primary key, foreign key helps in ensuring the consistency. Uh, so a transaction must see a consistent database. That is what is the need of the day. So during the transaction execution, uh, database may be temporarily inconsistent, but once the transaction is completed, the database will become permanently consistent. So if there is any errors in the transaction logic that we have defined, it may lead to inconsistency of the database. So last requirement is isolation requirement. So here in the example, if between the step 3 and 6, say for example, another transaction is taking place, which allows to access the partially updated database. So when, say for example, after the completion of step 3, another transaction is happening. So once the step 3 is completed, it means database is partially updated. It's not completely updated because transaction is not complete. So it will see an incomplete transaction. So for example, if I want to find sum of A plus B, the amount will not be correct. Am I right? Because by A plus B, what I mean is, so here A plus B is a transaction 2, which I'm talking about. A plus B is the sum of account balance of A and B. So initially, we have said like the account balance of A is 500 and account balance of B is 450. So at the end of step 3, I have reduced or I have deducted 50 rupees from account A. So now the balance of account A becomes 450 rupees. So here, what is the transaction T2? It is, so transaction T2 is A plus B. So what is the balance of A now? 450, because the amount 50 rupees has been deducted. Now again, what is the balance of account B? Again, it's 450 and A plus B will give a sum of 900 rupees. But is it correct? No. Why? Why? Because the transaction is about transferring amount from account A to account B. So 50 rupees has to be deducted from A and 50 rupees has to be added to the account balance of B. So actual amount of or actual A plus B will should give the result 950 rupees, which fails in this case because this particular transaction happens after the completion of step 3, where the database is only partially updated and it remains inconsistent. So this is what isolation is all about. So isolation should ensure the transactions are running serially. However, executing multiple transactions concurrently have may have significant benefits, which we shall discuss in the later part of this lecture series. So till this we have seen what is transaction and what are the various concepts of transaction and what are the various requirements of transaction. Hope you understood. In the next lecture series, we will see about the asset properties along with the transaction states. Thanks for watching and continue watching.